Welcome everyone to the next lesson in this series, and in this video we will look at securing Ingress communication with transport layer security using Cert Manager and Calico Ingress Gateway. Now in the previous lesson we configured Calico Ingress Gateway, but the traffic from the client to the server was using port 80, which is not secure. Now, in your production environments, you will secure traffic using transport layer security, for which we need a mechanism whereby we can, in an automated manner, generate as well as manage the lifecycle of certificates. So for that, in this lab, we will deploy Cert Manager and then use the certificates generated by Cert Manager for our applications with Calico Ingress Gateway to secure Ingress communication. So let's get started. All right, so in this lab, we have two applications, Store and API, and we will look at exposing these applications using TLS. Now for the Store application, we will use a wildcard certificate, and for the API application, we will use a domain-specific certificate to demonstrate these concepts. Now we will first start with Cert Manager, for which there are 3 steps. In step number 1, we will create a local certificate authority that can sign certificates for our applications. Now in production environments, you will use a public certificate authority, but for this lab, we will use a private certificate authority. Now to bootstrap a local CA, we need self-signed certificates for that CA. Now in Cert Manager for this, we will create a resource, a cluster issuer resource named self-sign, and this resource will be able to self-sign the certificates that we generate for our CA. Next, we will create our CA, which is also another cluster issuer resource named Lab CA Issuer. And this CA will use the self-signed certificate generated by Cert Manager as its CA certificates. And finally, as shown in this graphic, the Lab CA Issuer will be used to sign the certificates for our applications. Now, once we have the application certificates, we will create a gateway called TLS gateway, and this gateway will have listeners that will terminate TLS for the specified host names, namely api.demo.lab for the API workload and store.demo.lab for the store workload. Now, as can be seen in the diagram here, we have a wildcard certificate for the store application, namely wildcard-demo-lab-TLS, and we have a domain-specific certificate for the API application, which is API-demo-lab-TLS. Now, once the TLS gateway is created, we will next create HTTP routes, which will have parent references to the TLS gateway and the relevant TLS section in the TLS gateways. Now, these HTTP routes will also have backend references to our application pods based on the host names. So in this case, for example, we have one HTTP route for API, which will forward traffic to hostname api.demo.lab to the API pods. And similarly, traffic to store.demo.lab will be forwarded to the store workload pods. Okay, so with that lab setup in mind, next let's move to the lab guide. Just a reminder, there will be a link to the lab guide in this video and also instructions to set up the lab environment. I encourage that you follow along. Let's get started. Okay, so in my environment, I have already gone ahead and installed Cert Manager as well as deployed the applications for this lab. Now you can find the instructions to do so in the lab guide. Now with that out of the way, let's go ahead and check the status of the gateway class resource. Now in the previous lab, we checked what a gateway class is. And as you can see in this output, the Tigera gateway class is in a true status for this cluster. Next, let's go ahead and create the cluster issuer resources. Now on the left-hand side, you can see the definition of the manifest. We first have the self-signed issuer, which will be used to create a self-signed certificate for our lab CA. And secondly, you have the lab CA issuer, which will be the certificate authority that will sign the certificates for our applications. So let's go ahead and apply those manifests. Now, once the resources are created, let's check the status of those resources. The self-signed issuer is in a ready state. However, the lab CA issuer is in a false state. And if you look at the error message, it says lab CA secret not found. And that's because we have not created the certificates for our lab certificate authority. Next, let's go ahead and apply the YAML manifest for the lab CA certificate as well as the application certificates. There's no harm doing this in parallel. The application certificates will be signed once the lab CA comes up. Okay, so these are the definitions of our certificate resources. On the left here, you see the certificate resource for the Lab CA certificate. As you can see, the common name for this is Demo Lab Certificate Authority. And if you look at the issuer reference, this certificate will be signed by the self-signed issuer. Now, in the middle, we have the wildcard certificate for the asterisk.demo.lab common name. And this wildcard certificate will be used in the store application. And if you look at the issuer reference, it is issued or signed by the Lab CA issuer. Okay. And in the right, we have the certificate for API demo-lab. If you look at the common name, it says api.demo.lab. Again, the issuer in this case is the Lab CA issuer. So on the left, we have the certificate for the certificate authority, which will be signed by the self-signed issuer. So it's a self-signed certificate, as in it is signed by the certificate's own private key. And in the middle and the right, we have the certificates for our application. And these certificates will be signed by the Lab Certificate Authority. So next, let's go ahead and apply these certificates. And once created, let's check the status of those certificates. And now let's verify the cluster issuers again. Now, this time you can see that the Lab CA issuer is in a ready state. And that's because it had access to the certificate. And as a result, the certificate authority is now functional. Next, as an example, let's describe the wildcard certificate. And in this output, you can see the common name of asterisk.demo.lab, indicating that this is the wildcard certificate. We can see that it was issued by the Lab CA issuer, and we can see that this certificate is currently up to date and not expired, and it is in a true status. If you issue the described command for the domain-specific API certificate, you will get a similar output. Now, these certificates are stored as secrets. So the certificates for the demo application is stored in the cert-manager-demo namespace. And if you look at the secret, we have two secrets, one for API, which is the domain specific certificate, and the next one is the wildcard certificate. And if you look at the secret, it includes not just the certificate, it will include the private key, the certificate, as well as the certificate of the certificate authority. Okay. If you want to, for example, look at the contents of the wildcard certificate, you could do so by issuing the command on the screen. And as can be seen in this example, the certificate includes things like the issuer, the subject name, as well as the public key. So this certificate will be exchanged as part of the SSL handshake during client-server communication. Now, with our certificates provision, we are now ready to proceed to deploying the gateway for this lab. Okay, so on the left here, we have the definition of the gateway resource. You can see that it has first a port 80 listener, and this is for HTTP to HTTPS redirects. And after that, we have a listener for HTTPS-store. And if you look at the host name, it is store.demo.lab. And if you look at the TLS section, we will be terminating TLS. And the certificate reference points to the wildcard demo lab TLS secret in the cert manager demo namespace, which is where we created our secret, the wildcard secret for the store application. Now we have a similar definition for HTTPS-API as well, with a specific hostname api.demo.lab, as well as a specific certificate reference for that hostname. So let's go ahead and apply the gateway manifest. Once created, let's verify the status of the gateway. We can see that the TLS-gateway is in a true status. It has also received a load balancer IP 172.16.0.240, and we saw this in the previous lab as well. Now the TLS section was referencing certificates which were in a different namespace in the cert-manager-demo namespace. Now, if you describe the gateway, we can see that it does not have permissions to access those secrets. Any guesses? We looked at this in the last lab as well. The gateway cannot access resources in other namespace unless we have a reference grant that permits it to access those resources. So next, let's go ahead and create those reference grants. Now on the left here, we have the reference grants. The first one is so that the gateway resource, which is the default namespace, can access the services in the cert-manager-demo namespace. And the second reference grant here is for the HTTP route, which we will create subsequently to access the services in the cert-manager-demo namespace. Now, we could have combined this into a single reference grant as well. However, we've shown this as two separate grants for brevity. Next, let's go ahead and apply those reference grants. And once done, let's go ahead and create the HTTP routes. Now, if you look at these HTTP routes, they're going to have host names, and as parent references, they will be referencing the TLS gateway and the relevant sections in the TLS gateway for the application or the host names that we have configured in the gateway. These these HTTP routes will also have backend references for the respective application endpoints. Now, once the HTTP routes are created, we could do a kubectl get HTTP route. We see 3 routes in our case. The API-route is for the api.demo.lab hostname, and we have a HTTP redirect route as well. And that's because if someone sends traffic on port 80, we will redirect them to port 443. And we have a store-route, which is for the store.demo.lab hostname. All right, so with those routes created, we have now completed the lab setup. So next, let's test this lab setup. Now to test this, we are going to initiate traffic from the user to the IP of the gateway, which is 172.16.0.240. We looked at this in the previous lab and the setup is pretty much the same. So if you need a refresher, please refer to the previous lab. Now in this lab, we don't have a DNS for the user. So what we're going to do is we are going to create some host entries in the user's host file for our applications, store.demo.lab and api.demo.lab. So as you can see, if the user sends a DNS query to either of these host names, it'll resolve to 172.16.240 as per the configuration in the host file. Now with that host file configuration in place, let's do a curl from the user to store.demo.lab. Now, as you can see in the output, this curl fails with a message that it could not verify the legitimacy of the server. Any guesses as to why? Well, in this lab, we have created a private certificate authority, and our user does not have the certificate for this certificate authority so as to trust this certificate authority. So next, let's go and import the certificate of the certificate authority to the user container. Now to do so, we will first retrieve the CA cert from our cluster and then copy the CA cert to the user container. Next, we can issue a curl to our application by referencing the CA cert, as you can see in the --CA cert flag here. And this time, the certificate was verified and our connection was successful. Next, we will do a similar test for api.demo.lab as well. This time too, our certificate was verified and the connection was successful. So now we have end-to-end communication from the user to our backend workloads, protected using transport layer security, and the TLS gets terminated at the ingress. And from the ingress, traffic is sent to the backend endpoints using port 80. And that's okay because that traffic is internal to the cluster. So that's it for this lab test. All right, I hope you enjoyed that. And just a reminder that all of the content and all the steps we covered in this video is available to you in the lab guide. Now you can follow the instructions to spin up the lab and try these yourself. So that's it for this video. I hope it was informative. Thanks for watching, and I'll see you in the next one. Bye for now.